So your MacBook Air has no display. It has a green light, it has a fan spin, it's taking some load, but there is no display. If your MacBook Air has the same symptoms, this video is definitely going to help you. So hi, this is Fahad from Future Phones, and today I am working on a MacBook Air. The model number is A1465. It has the same issue, it has no display. Let's get to the work and let's try and fix it. So my power supply is set to 16.45 and 3.5 amps, and I'm going to connect it to the DC board, and you can see when I connect here I get a green light, and you see instantly I get a green light. The fan starts spinning, LCD is connected, and there is no display. It's completely blank. There is two things are noticeable on this board before we get to work on this board. One is the fan spin. It's not normal. In a normal fan spin, it's not that loud, it's not that fast. Okay, so it's working more than it's supposed to work. That's why there is a loud fan spin. So definitely there is some heating element, or if the motherboard's power plant is not going into the next level, the fan will work continuously and it will work really fast. One more thing, you can check here on my DC power supply here is stuck at 0.563. If your board reaches to 0.700 milliamps, there will be a display. When you connect it the very first time, you can see this starts at 0.23 milliamps, 26 milliamp, and then it goes to 340, 500, and it is supposed to reach to the next level, which is the 700 milliamps. If your board can make it to 700 milliamps, there will definitely be a display on the screen. Right now we are stuck at 510 milliamps. After 500 milliamps, the board works in the data level. What that means is from 0.23 milliamps to 300 milliamps, this is purely power consumption, and after that when it reaches to 400, 500 milliamps, then the data, clock, and these things, they start to work. Because don't forget, the motherboard has not only got the power, but it's also got the data. So once at 400 milliamp and 500 milliamps, the data starts to kick in. So in this condition, 0.5600 milliamps, what are the things that needs to be checked? Because our power level is almost clear. What needs to be checked is the BIOS, your RAM, and your hard disk. All these ICs, they have data in there. So if any of these are faulty, the board will be stuck at 500 milliamps or 600 milliamps. This is our theory. Let's check the board now. So our LCD connector is good. This is also related to the data lines, because data is supposed to travel through these lines. If they are short, you can still have problem. You will have a problem of data not being displayed, and so this is the CPU area. Obviously this is the main hub for the data also, so there is so many data lines going in there. Check, looks fine. So this is our SSD section, and we find no issues here. Looks clean, nice, no physical problems at the moment here. Okay, let's go check the BIOS. Usually BIOS has corroded pins, and they can cause this issue also. This area looks okay. There is some dirt here in this section here. Let's see what it is. That can be removed. So it's just some dirt here, is nothing major here in this area. Check the RAM section. Oh, flux. You see flux here, and you can see a Hiroshima here. Something is not right in this area here. So this area is corroded. Possibly it was liquid damage here. So that could be our issue. Let's check more. So the board otherwise looks okay. So there is this area here. You can see this area is severely damaged. So we need to work on this area, and it is next to the RAM section. So most likely is some power rails for the RAM. These are our RAM ICs here, and if there is a problem here, then definitely this board is not going to power on. So let's see what we can do on this board in this area, because this looks really bad. You know, the conditions are not right here. This board has been to another shop, and initially it was liquid damage and they tried to fix it, and I believe that this was the area where they tried to work on. They just cleaned it and thought that it's gonna work, but it's not how things work actually. If there is a damaged tracks or damaged parts or damaged component, they just don't need cleaning only, they need to be fixed as well. The track needs to be rewired, so then the things work in electronic circuits. So I believe that there is a resistor, one component is missing here and another component is missing here. For this I will need to open my board view. This area actually it is supposed to look like this. So there is one resistor, one capacitor, and then there is another resistor. So the bottom resistor has a ground here, and this is supposed to be here connected, and then we have a capacitor here, then we have another resistor here, and this resistor has this pad connected to this IC. Pad number 1 is connected to this IC here, and pad number 2 is connected to these resistors. So let's check this first, R2243. What I need to check is that this resistor is connected to this IC and this side of the resistor connected to these two pads, and I need to check if it's going to the C2641 also. So that's the first thing I'm going to check. Okay, let's go to the microscope. So this is our resistor here. So what I wanted to check was, so what happened, I don't know what happened. So yes, I don't know, we just missed it, the recording is stopped. So yes, let's see what I was doing here. This is so I made a connection of this resistor here, you can see. So this resistor is connected to here now, so we have a good connection here. So this is the wire I was going to pull, and I'm going to pull this wire. I'm going to get it to this capacitor here. I'm going to give some length. So I'm going to connect here. So connect this cable here. So what this line is complete now. So yeah, thank you very much for subscribing and appreciating, and for the likes and comments, everything. I wasn't expecting really such a good response, and I'm really very happy that we are building up a community where we will share ideas, and most of all we'll try and help people, no matter what job you do, but as long as you are helping people in whatever way you can help people, by fixing devices for people who really need their devices, instead of buying a new one, or if there is any sentimental values attached to the devices and we can fix them devices for them. It's really an honorable thing to do, and I really love that. Okay, anyway, so now this is complete. Now second thing is we need to see what we can do here, because something is also needs to be done here. So I will go to the desktop again, because I need to see what is that required here. So we have one capacitor here, and this capacitor is attached to this resistor, and we can check what capacitor is this, and we have a resistor. Resistors are more important than capacitors usually. So if there is a capacitor, then if there is a resistor, then we must install that resistor, and if there is a capacitor, you can skip it sometimes, but you can only skip it when you know that if you skip it or if you don't install it, it's gonna be okay. Usually I can give you one tip, but it doesn't work all the time. If the capacitor has one side connected to ground, then you can just skip it. But in this condition, you can see we have a capacitor here, and what is this capacitor doing? Connected to this resistor. And what about this one? This is connected here. So in both cases, this capacitor is not connected to ground. Realistically, we cannot miss it. We should install this capacitor, but this resistor is mandatory. We must install this resistor, and to do this I will search what resistor is this, and hopefully I'll find it. And this is a 24.9 ohms resistor. So I have a similar board actually, and I'll try and find it if I can find it. So I can, this is a donor board. I can take this resistor and place it there. So let's try and get this resistor out. Okay, 480 and 30. The air is 30, temperature is 480. I mean, there are some practices very commonly famous, or everyone talks about it, that if your device has gone faulty or liquid damage, put it in the rice. I mean, this is utter rubbish. Electronic components, they must be fixed properly or replaced. Even one small drop of water at a wrong place can put your computer down, or you put your motherboard down, and it will be good forever. So these things are very important. These components are important. You cannot just clean it with a brush and expect it to work. Even the values of these resistors, that is important. We mostly in resistors you cannot use a different value resistor. It has to be the exactly same value resistor to get the circuit working properly. Install this resistor here. Now I can do one more thing. I know that this resistor is here, and this I have only one pad for this resistor. Don't know why it's so black. So the other pad I can use this test point. Let me just confirm it. So what I'm going to do is yeah, so if I take you to the desktop, I want to tell you what I'm going to do here is so that's what I'm planning to do right now. So this resistor has this area connected to ground, and this area is connected here. So we found the ground for this resistor, but we do not have this connection. This pad is missing off the board, so I'm going to throw a wire from this end to here. Okay, throw some flux in. Flux is always helpful. Make your job easy. Always use good quality flux. And for the tools, I know one thing, that always use the best tools, and then if things don't work, then it's you personally, not the tools. Otherwise you will always have this ambiguity that oh, probably my tools are not right, I am working right. So once you have the right tools, then only you need to improve yourself. You know that your tools are 100%. So yeah, if you are sorry, I'm gonna take you to microscope. I made another jumper here. So yeah, this jumper is done. Let's clean it and have a look.
I've done it right. So yeah.
We have a good connection. Get rid of this extra. Can you see now? I know it's a bit difficult, but it's a very small jumper, so now you can see that this is connected here. Now we need a capacitor, and that capacitor will connect to both resistors. And to do that, what we need is a capacitor. Okay, so let's find it from the donor board again. I'll just do it this part myself, so let me find one. It's 0.022 picofarad. So this is probably the capacitor. Yeah, I'll just grab this capacitor. So that's the capacitor, is 0.022 pico to 22 picofarad capacitor, and I'll put some flux here so it just stays in. Let's think about it, how we can place it. And sorry, it's just material. This is nightmare. Okay, let's take you to the desktop and let's think about it, how we can put this capacitor. So this capacitor has this pin connected here and this pin connected here. So yeah, that's what I'm going to do. I'm going to put this capacitor's pin number 1 to this jumper point here, and then throw a wire from pin number 2, and I will throw this wire to this pad here, this testing pad. I'm gonna put air down a little bit, about 20. Don't want to disturb those wires. Hopefully they don't get disturbed. So this capacitor is connected to this pad now. All I need is a wire, and that wire will connect to the pad. Okay, that I can do quickly, shouldn't be a problem. So I'll tin this wire first because it will be easier for me. Okay, I'll connect this wire to this capacitor now. And that's it. It's done. Sorry, you cannot see it properly really, but there's too many shades. Okay, this came off. I was expecting it because it wasn't best of the connections. So that's it. It's done. It's connected properly now. So this circuit is complete. That's how it looks right now. So that's how it looks, isn't it beautiful? Yeah. So let's just make some measurements. Let's check if what we have done is right or not. First of all, I need to check, I need to check if this pin is connecting all the way to this capacitor and then this resistor. That's fine, good connection. This resistor is supposed to connect to this cap, or is not connected, or what? It's connected. Okay, this side is supposed to connect to this pad, which is okay. This is our ground pin. Ground is okay. Okay, let's check what we were missing last time. It was not going to 700 milliamps, so I want to check now. So let's give some power now and let's check what happens. So we have a green light and we are reaching at 892 milliamps I wish I could show you this one here, and it's doing a reset as well. Wow, I think this fixed. $395, $389, and 392. Okay, well, I think it's after the reset. Let's do one more time. Okay, let's check the readings. So it's a 500, 600, 800, 724, and now it's a reset. This was not happening before. It was stuck at 560 milliamp, 724, and it's just doing again 800, 464. Well, something is different. Let's give it a try. Let's check the display. So everything is connected like before. I've connected the LCD, power is connected. Let's see, do we have a display? Apple logo. Something is different. Come on, you should get something here. Come on. 576 milliamps, 472, 577 milliamps, 572. Yep, we have a folder sign. That's it. So this is fixed. How great is that? So you can see, I'll show you, I'll try to show you. Look, we have a folder sign. Yeah, so we have a folder sign. Look, we have a folder sign. Look, so it's working. So only that area was faulty, and you know, that circuit was broken. As I said before, you know, that somebody's tried to work on it. This company, they were trying to fix it. They did not build the circuit again. They just cleaned it. Electronics circuits do not work if they are faulty. If there is a short circuit in there, or if the tracks are broken, just by brush and cleaning, it doesn't work like that. So you need to properly build the circuit again, and once the circuit is built, then it works. Most of the time it works really, and it's not like all the boards have the CPU have a problem. It is a reality that CPUs are having more problems than before. They are dying more now because there's too much work involved in the CPU and PCH. They're all together now, so they do fail, but most of the time these are the small things. When you try to clean it with the brush and it doesn't work, and then you say, oh yeah, the CPU is faulty. So don't misguide your customers, and I mean, just do your job properly. That's all it is. Now really sincerely, I want to thank all the subscribers. I've got like more than 2,000 subscribers so far. I want to thank you all. Thank you very much, and your comments and your likes and your shares, they mean a lot to me. And whenever you leave a comment, it really boosts my energy and my confidence level that I should work more. And if I am trying to give some information out, whatever I know, obviously nobody can claim that he knows or one knows everything. Everyone knows little bit or few things. So if you can share what you have, I think that's the best thing you could ever do. So thank you for watching, and I will see you in the next video. Keep subscribing, keep liking and sharing the videos. Thank you very much, and I'll see you in the next video. Thank you. Bye.